Hi there. Welcome to another tutorial of Engineer Gene. So for today, we will have the introduction to limits. Before we formally discuss, let's first have the definition. So the definition of limits is that the behavior of function close to a certain point. So that defines that a function has a value to that certain point. So let's have an example to further understand. So example here is f of x is equivalent to x squared as x approaches 2. So we can substitute a value or approximate a value for x that is equal to 2. So let's substitute 2. So therefore, f of 2 is equivalent to 2 squared. Therefore, f of x equals to x squared is equivalent to 2 squared or 4. Exactly 4. So that means that the limit approaches to a close point to 4, but not exactly as 4. So that means that there is a limit for the function. So therefore, the notation from the definition above can be written as limit of x to a certain value, uh, then substituting the certain value to f of x will have a limit L. So let's have the other examples. So first example, we have the limit approaches, the limit of x approaches to 2, wherein the function is 1 plus 3 of x. So we can clearly say that uh, x, x approaches to 2. Then we can substitute the value for x or approximate a value for x which is equivalent to 2. So that will be 1 plus 3 multiplied to 2. So 1 plus 3 times 2 is 6. Therefore, the limit is equivalent to 7. If we will have our calculator, so we can solve it in via our calculator. So just press AC, then type in the equation 1 plus 3x, then press equals, then the start will be from the negative side, which is, I think we can start at the not just the negative side, no? So we can start at the positive side. So let's start at 1, I think. So we can start at 1, then we can end at 3. So we need to approximate a value close to 2. So the step will be 0.1. Okay, so as you can see, as the x approaches closer to 2, the value approaches closer to 7. Then, as well as, uh, if the value from 3, so if the value is 3, then the number decreases, approaches to 2. So it approaches to 2. Therefore, the limit can be equivalent to 7. Okay, so you can solve it using the calculator. Next, let's have the other example. So limit uh, x is equivalent to negative 1. So we can clearly substitute the value here, which is negative 1. So therefore, that one will be uh, negative 1 squared plus 1. So this one will be equal to 1 plus 1, or clearly we can say that the limit is 2. The limit of x, the limit of x approaches to negative 1, x squared plus 1 is equivalent to 2. Okay? Also, you can solve it in our calculator by applying the method that we have earlier. Next, let's have this limit. So the limit, as x approaches to 1, then the function is x squared minus 1 all over x squared plus 3x minus 4. So If we will substitute 1 here, therefore it will be equivalent to 1 squared minus 1 all over 1 squared plus 3 times 1 minus 4. So substituting this, we'll have 0 all over um, 0 all over mm, 0 all over 4 minus 4. So this one will have a value of 0 all over 0, which is equivalent to indeterminate. So since the function is indeterminate, we need to apply another method so that we can clearly define what is the limit in this equation. So let's try to factor out the equation x squared minus 1 and of course the equation below, which is the x squared plus 3x minus 4. So let's factor out x squared minus 1. So the factor for x squared minus 1 is equivalent to x plus 1, then x minus 1. Then the other one is x. This one is x x plus 4, x minus 1. Okay? So we can clearly say that this one is the factor of the other equation. Wait, let me rewrite it first. So the equation that we factored earlier is x squared plus 3x minus 4, equivalent to this one. Then we can clearly rewrite the equation here. So in our numerator, we have x plus 1, x minus 1. So that one will be, let me rewrite the equation. So limit x approaches to 1, then that one will be x plus 1, x minus 1. Then on our denominator, we can rewrite it as x plus 4, x minus 1. Therefore, we can cancel out x minus 1 here. And then uh, the equation becomes x plus 1 all over x plus 4. Then we can substitute the values, which is equivalent to 1. So that one will be 1 plus 1 all over 1 plus 4. Therefore, the limit is equivalent to 2 all over 5 or 2/5. Okay? So let's try in our calculator to solve for this equation. So let's try it. So I will just clear my calculator. So this one will be x squared minus 1 all over x squared plus 3x minus 4. So press equal. Then we need to approximate a value closer to 1, which is we need to start at 0. Then we need to end at 2. Then the step will be 0.1. Then uh, let's try to browse the values. So as x approaches 1, so the equivalent is error, no? So error. But the approximate value is 0.3877. So this is closer to 2/5 that we have here. Okay? So also the other value, 0.4117, clearly says that it is closer to 2/5. Okay? Because if we substitute exactly 1 to the value, it will display an indeterminate symbol or answer. So that's why the calculator also displays an error. So let's try to go to mode computation. Then let's try what is the value of 2/5 in decimal. So the value of 2/5 is 0.4. So the values that we approximated earlier are closer to 0.4. Okay. All right. Next, we have limit as x approaches to 1 of tangent of the function tangent x all over sine 2x. So if the function is already trigonometric identities, so we will use the trigonometric identities of this problem. Then we can clearly say that tangent x is equivalent to tangent x is equivalent to tangent of x is equivalent to sine of x all over cosine of x. Then the other one is sine 2 of x. This one is a double angle formula, so we can clearly say if we will recall the trigonometric identities, so this one will be 2 sine of x cosine of x. Okay, so let's try to substitute these equations to the original equation. So let's have it. So limit x approaches to 1. So therefore, the equation here will be sine x over cosine of x all over 2 sine x cosine x. So let's simplify this equation. So therefore, this one will be sine of x all over cosine of x multiplied to 1 all over 2 2 2 sine of x cosine x. Therefore, we can cancel out sine x here, then multiply it by cosine x. So therefore, the equation here will be equivalent to uh, 1 half, 1 half, 1 all over 2 cosine squared of x. Therefore, we can substitute uh, value of x is equivalent to 1. So that one is the limit, approaches to 1. So we can clearly uh, substitute it, then 1 half cosine squared of 1. So we clearly know that cosine squared of 1 is equivalent to 1. Okay? So let's try in our calculator. So cosine x squared, calc x is 1, equivalent to closer to 1. Okay? So closer to 1 if we round this off. So therefore, the limit here is this one will be 1. Therefore, the limit is equivalent to 1 half. Okay? So that one will be the limit in this equation. So let's have another example, which one is this one. So the limit of x approaches to pi over 6 is equivalent to, wala pa palang value. The limit of x approaches pi over 6 to the equation sine 2x all over sine x multiplied to tangent x. So let's try to have the trigonometric identities for this equation. Okay, so we all know that sine 2x is equivalent um to the double angle formula of 2 cosine x sine of x. Then we also know that tangent of x is equivalent to sine x all over cosine x. So let's try to simplify the equation above. So that one will be sine 2x is equivalent to 2, 2 cosine of x sine x all over sine x multiplied to sine of x all over cosine of x. So this one will be equivalent to 2 cosine of x sine x all over sine squared x over cosine of x. So using the reciprocal of the function below, this one, of the equation below rather, so this one can be simplified to 2 cosine of x sine x multiplied to cosine of x all over uh, sine squared of x. Therefore, the sine of x will be cancelled here. Then this leaves the equation to equivalent to um 2 cosine of x. 2 cosine of x multiplied to cosine x is 2 cosine squared of x. So that one will be 2 cosine squared of x all over sine of x. Okay, so that one will be the equation, but still it's not the final answer. So we can still simplify this equation because 2 cosine squared of x has a power reduction identity. So let us recall the power reduction identity of 2 cosine squared of x. What is the power reduction identity of 2 cosine squared of x? So that one is equivalent to 1 plus cosine 2 theta all over 2. So if we will simplify this one, it will be 1 half plus 1 half cosine 2 theta. Okay? So this one will be we will use this trigonometric identity. Okay? So since this is x, so we need to adjust the the identity here. So we need to use x. Okay? So that one will be the identity. So if we will simplify this one, so it will have 2 multiplied to 1 half plus 1 half plus 1 half cosine 2x all over sine of x. Wait, there's more. So this is not still the final answer. We can clearly distribute 2, distribute 2 to the inside. Okay, so distribute 2. So if we will mm, simplify it, so it will be equivalent to 1 plus cosine uh, 1 plus cosine 2 of x all over sine of x. So we all know that if we will convert pi all over 6 to degrees, so this one will be 30 degrees. Okay? So if we will substitute it to the equations, so it will be 1 plus cosine 2 times 30 degrees all over sine 30 degrees. So let's try to solve in our calculator. So that one will be 1 plus cosine 2 multiplied to 30 all over sine of 30. So that will be equivalent to 3. Equal to 3. So therefore, the limit here is 3. So that's it for this example. So next, suppose that we have one of the following cases. So let's say we cannot solve it via trigonometric identities anymore. Let's say substituting the limit of x is still the same. So without the aid of that solution or approximating the values to trigonometric identities, if it will yield the indeterminate values, so therefore we will use the all L'Hospital's rule. Okay, so we will use the L'Hospital's rule that in wherein we can have the derivative of the function. So let's have an example. So this one is a good example. So the first example is limit of x approaches to 0, sine 0 all over, sine of x all over x. So if we will directly substitute this equation to 0, so that one will be sine of 0 all over 0. So this one will add 0 all over 0. So therefore, this one is equivalent to indeterminate. So if that happens, we need to use L'Hospital's rule. So let's have the space below. So at A, using L'Hospital's rule. So let us have the rule. So let us rewrite the rule. So we can clearly say that the rule here is limit. So limit of x approaches to A, that one will be the derivative of this equation all over the derivative of this function. Derivative of that function all over the derivative of another function. So if we will rewrite the equation for A, so that one is sine of x all over x. Sine x all over x. So if we will apply the L'Hospital's rule, therefore, we will have this equation. So the derivative of sine x all over the derivative of x. So we all know that the derivative of sine x is equivalent to cosine of x all over 1. So substituting the value for x is cosine 0 over 1. We all know that cosine 0 is equivalent to 1. So therefore, this one will be equivalent to 1 all over 1 or clearly 1. Exactly 1. Okay? So that one will be the solution for the first problem. So how about the second problem? So if we will substitute here 1, let's try to substitute 1. So that one will be 5, 1, 4 minus 4 multiplied to 1 squared minus 1 all over 10 minus 1 minus 9 times 1 cube. So if we will substitute that, this one will be equivalent to 5 minus 4 minus 1 all over 10 minus 1 minus 9. So that one will be equivalent to this one will 5 minus wait lang. Hmm. 5 minus 4 is 1, then minus 10 is 9. Hmm. Then on the other hand, 10 minus 1 minus 9 is all over 0. 0. Then this one, 5 minus 4 is 1 minus 10 is 9. Negative 9. So a number divided by 0 is equivalent to indeterminate. So if the number is equivalent to indeterminate, therefore, um, we can apply the L'Hospital's rule here. So applying L'Hospital's rule to problem B, limit of t approaches to 1. Limit of t approaches to 1, so that one will be 5t4, t to the 4th minus 4t squared minus 1 all over 10 minus t minus 9t cubed. Let's try to have the derivative of the first function, 5t4 minus 4t squared minus 1 all over the derivative of the another function, which is 10 minus t minus 9t cubed. So we can apply here the chain rule for the derivative of both functions. So if we will have the derivative, so this one, the first equation will have this result. So 5t to the fourth will have 4 multiplied to 5t 4 minus 1. So we will employ the chain rule method. Then minus the derivative of this function 40 squared is 2 multiplied to 40 2 minus 1. So that one will be the derivative of it. Then derivative of 1 is clearly 0. Okay? Derivative of 1 is clearly 0. All over the derivative of 10 is 0 minus the derivative of t is 1 multiplied to t 1 minus 1. Then the derivative of 9t cubed is uh, 3 multiplied to 9t 3 minus 1. So let's simplify the equation. That one will be um, This one will have 20t cube minus 8t 1. Okay? All over minus 1 minus this one will be 27t squared. Okay? So that one will be the simplified format. Okay, so let's have the value for x. The value for x is 1. For t, rather, for t. For at t is equivalent to 1 or t approaches 1. So if we will substitute that, so 21 cube minus 8 multiplied to 1 all over negative 1 minus 27 1 squared. So if we will simplify this, 20 minus 8 is 12 all over 28, negative 28. So if we will simplify 12 over negative 28, so that one will be equivalent to uh, 3 over 7. So this one will be equivalent to negative 3 all over 7, which is the final answer for this problem. So let's try in our calculator to simplify it. So 12 all over 28 negative. So that one will be equivalent to negative 3 over 7. So correct. Therefore, that concludes our lesson for today about limits. Okay? I hope you gained something in this tutorial.